So I wrote an article titled From Zero to OpenShift in 30 Minutes. Now this is to install a full OpenShift cluster with multiple worker nodes. Today I'm going to use the same article to install a single node OpenShift cluster, and I think we can do this in much less than 30 minutes. I'll post a link to the article in the YouTube description. So a couple of things first. You'll need a reasonably fast machine with reasonably fast I/O. I recommend a machine with at least 8 cores of CPU and ideally NVMe storage, or what I have found works quite well is NVMe or SSD storage in front of a traditional hard disk. I found that adding even a 10 gig LVM cache on a fast NVMe drive is enough to significantly speed up all I/O to a terabyte of physical spinning disk. But if you can do 100 gig NVMe or even more, then most of your I/O will end up being cached. So onto the installation. I'm using a command line tool called kcli. The link to this, well, it's on GitHub, and you can find the link in my documentation. I will start off with just cloning this repository. It's actually a very useful tool. It isn't just for OpenShift, it's for all manner of VMs. It's worth checking out the website. It does a whole load of stuff, and it simplifies things massively. So we have that cloned. I'll go into this, and I think I need to sudo the install, and yeah, I already have it installed, so there's nothing to do, but that's fine. Now I've created a directory called OpenShift where I'll just put my configuration files. This already exists because I've already done this, but I will check the configuration. On the documentation here, I've got configure parameters.yaml, and there's a guide on kcli for all the parameters that exist. Most of them are optional. Most of them have sensible defaults if they're not specified specifically. So let's have a look. Parameters. Right, so I've already done this once before. We're taking the stable branch, the 4.13 tag, which is the latest. Normally I would have 3 control planes and 1 or more workers, but today we're just going for the single node OpenShift install, so it's simply 1 control plane, nothing else. Memory, I think with single node OpenShift you can get away with less, but I'm going with whatever number this is. It was I couldn't remember the exact number of megabytes in 32 gigs, sorry. Number of CPUs 16. I don't think it matters massively for OpenShift, but as I say, at least 8. And I will also say here, if you're deploying too many machines or too many VMs, if you're not doing the single node OpenShift install, the OpenShift installer can time out waiting for things to become available, waiting for the API to become available. There's a couple of RFEs, or at least one RFE open to address this, but at the moment that's the situation. So if things do time out, if you're trying to deploy a large cluster and your I/O is not quick enough to do it within the 30 minutes, I think, then you may need to run the installer multiple times. But that won't be the problem today. So we have our parameters. The only other thing I haven't done, which I should have said at the beginning, is you need the poll secret, which you can get from cloud.redhat.com. I'm not going to show it here, but I'll show it in my directory. So you can see here I have my OpenShift poll JSON file, and I have my parameters.yaml. The only thing left to do now is to deploy the cluster. And this is probably where we want to time it. I can see the time is coming up to 12:15 locally. I might even time this command. Let's see how fast we can do this. So this is a i5-12400F, which is the fastest CPU I could get without the troublesome E-cores. I have 48 gigs of RAM and NVMe storage, so let's see how fast we can do this. We can see here waiting up to 20 minutes for the Kubernetes API, which I think this is the part that sometimes times out if you don't have fast enough storage and you're deploying multiple nodes, multiple worker nodes typically. We're now waiting for bootstrapping to complete. At this point, it's interesting to see that this seems to be mostly a CPU-bound exercise and mostly a single core, bound to a single core, which is limiting performance. Disk I/O is minimal, mostly minimal, but one core seems to be pegged at 100%, which is probably the installing VM. While this is installing, I can show you the kcli. It's well documented on GitHub. There is a very thorough documentation available as well, which is linked from here. And you can see the different providers it supports, and further down, I think, deploying multiple clusters. It's really quite a useful tool. Yeah, it takes installation of a complex package like OpenShift from... I mean, before this, it was taking me quite some time just to go through the basics required, the prerequisites for installation. Even with practice, it was taking longer. With kcli, it's really a case of just installing kcli, creating the configuration or the parameters file, grabbing the poll secret and hitting go. We're seeing much more multi-threaded action now. I'm guessing the bootstrap node is built and there's multiple processes starting up. So we can see disk writes are about 20 megs a second, which is not too significant, but when you're deploying 5, 6 or so machines at once, this quickly escalates and can quickly saturate a standard spinning hard disk, which is why I think it's so important to either have fast NVMe storage or, as I often do, the LVM cache. Some very fast NVMe storage, the fastest I can afford, even if it's a small amount, put in front of a traditional hard disk. But I think in this instance I'm installing to a libvirt directory, which is actually directly on the NVMe itself. I should also add, if there's any issues or you want to monitor progress, you can SSH to the bootstrap node and you can follow the log files or the journal. I won't do that here, but it's documented in my blog, which again I will link to in the description of the video. But you use vir-sh to find the temporary DHCP address of the bootstrap node. You SSH to it as the core user. It will use your default SSH key, which you've hopefully already created. Well, you would have, or the installer won't be working. And then you just use journalctl to basically tail or follow the bootkube service. This isn't really necessary, but if you have problems or things seem to be hanging or taking an unusually long period of time, then it can be useful for debugging. And we can see now that the install plus my running desktop applications is actually using the 32 gigs of memory. So bootstrapping is complete, and we're now waiting for the final step for the cluster to come up and the API to be available. So I'm watching this. I quite like to see all the CPUs busy, because that means all the processes, all the operators and everything are probably starting up. I also notice in HTOP that although there's 38 gigs of RAM assigned, virtual, I can't remember exactly what that stands for QEMU or libvirt, only 20 gigs is actually currently reserved or in use. So you could probably get away with deploying a single node OpenShift cluster with maybe 24 gigs, depending of course on how many applications you then later deploy on top of it. And there we go, 22 minutes. So maybe I can name this video from 0 to OpenShift in 22 minutes, or at least 0 to single node OpenShift in 22 minutes. So we have the info provided here. It's worth making a note of this. You can retrieve it afterwards if needed, but I always copy this to a file just out of habit, makes it easier for myself. We can export the kube config. Wonderful, and we should have the web console up as well. There we go, 0 to OpenShift in 22 minutes. And I should say kcli, as well as installing the cluster, obviously this takes care of all the VM networking and DNS as well. So any applications deployed, you don't have to manually update DNS configuration or play with host files or anything like that. So there we go, I hope that's been useful. Again, my documentation on my blog I will add to the link of the video, the description of the YouTube video. Yep, and again in that documentation there's the full documentation for kcli, which I recommend you read. If you've got any questions or any issues, feel free to add a comment and I will try to get back to you as soon as I can. But thank you for watching, I hope that's been useful. Bye bye.